Europa, Ganymede, Enceladus. All moons in our solar system with one thing in common. They're suspected to contain liquid water below their icy surfaces. Experts think that if there is life beyond Earth, these massive oceans are the place we're most likely to find it in our solar system. There's an increasing number of missions and proposals to explore these untapped water bodies, starting with an expedition to one of Jupiter's moons. It's called the Europa Clipper mission. In 1977, during a mission to photograph the barren volcanic floor along the mid-ocean ridge, scientists found something that totally changed our understanding of where life can exist. The seawater percolating into the seafloor was being heated by magma, and then rising to discharge as hydrothermal vents, and those vents were supporting a previously unknown ecosystem. Before then, it was thought that most animal life depended on energy from the sun.
We do have these gases that contain a lot of energy, and because of that, there are bacteria living around these areas and other microorganisms that are able to extract energy from those gases and use it to produce organic matter.
And that matter feeds an array of exotic animals. This discovery has big implications for planetary bodies in the universe with water, regardless of whether or not they're close enough to harness the energy of their host star.
It suggests that there's the possibility that there might be life on other planetary bodies that have water. And so, in some ways, this discovery is helping change our ideas about the potential for life on other planets.
In the decades since the hydrothermal vent discovery, evidence has piled up for oceans in the outer solar system. Both the Galileo probe that visited Jupiter and the Cassini probe that visited Saturn were equipped with an onboard device called a magnetometer, which was able to give substantial evidence for liquid oceans. But life, as far as we know, needs more than water. There needs to be an energy source like the sun or similar processes that create hydrothermal vents. So when the Voyager mission flew past Jupiter's moon Io in 1979 and witnessed volcanic plumes, scientists were thrilled to confirm that these frozen bodies were more active than previously thought. Tidal heating is also the reason for the volcanic activity on Io observed by Voyager. But there are other reasons for making Europa the top priority. While some moons in our solar system have many craters, Europa has few. And this means that the surface is probably very young due to an ocean that causes the surface to warm and crack, changing the landscape and erasing craters. Now all we need to do is get there.
Europa Clipper is prepared to launch in 2024. We have really amazing cameras that are going to take higher resolution images than ever before. We've got some imaging spectrometers. These are instruments that will be able to tell us what the composition of the surface is. We'll have a magnetometer, a fancy compass, to be able to understand more about Europa's interior ocean. We'll even have a radar sounder so that we can look for near-surface water reservoirs too.
Color and infrared cameras will map the surface and search for hotspots where material from within Europa, possibly the ocean, may reach the surface. It will be the first mission sent to specifically study a moon other than our own. The mission will place the Clipper spacecraft, which is longer than a basketball court, in orbit around Jupiter, where it will perform about 40 flybys of Europa. The spacecraft may even be able to sample particles high above Europa's surface. During past Earth observations, and observations from the Hubble Space Telescope, scientists have seen something that looks like plumes of water or other material on Europa. Clipper will be equipped with the right tools, and will be able to fly close enough to analyze those plumes if they do indeed exist. Although the main goal of Clipper is to understand habitability on Europa, Not all of the questions regarding life can be answered from flybys. That's why NASA is proposing a follow-up mission to launch in the next couple of decades that could land on Europa. The European Space Agency is also sending a probe in the next couple of years, called the Jupiter Icy Moons Explorer, or JUICE. It will spend at least 3 years studying Jupiter and the habitability of 3 of Jupiter's moons, Europa, Callisto, and Ganymede, the last of which was recently found to have possible water vapor coming from its surface. And there are even more ambitious proposals to explore subsurface oceans in the far future. Finding even microorganisms would undoubtedly change our understanding of life and the boundaries of the habitable zone, the area around a star which we think could support life as we know it.
Really, it's caused us to change our ideas for where we might look for life and how abundant habitable conditions might be in the universe.
Since many planets around other stars, known as exoplanets, are now thought to contain liquid water, these expeditions may tell us more about which of these planets are potentially habitable, and bring us closer to answering the age-old question of, are we alone?
You know, this universe is so vast, so immense, so amazing. Are there other worlds that could be, more incredibly diverse beyond our wildest dreams and have life of their own? Or are we just incredibly, horribly alone? I hope it's the first one.